Welcome to the Explainer. If you've ever found yourself staring at a GKE setup and wondering how it all actually works under the hood, you're in exactly the right place. So today, we're going to pull back that curtain and demystify GKE networking, all the way from the VPC it lives in to the load balancer that serves your app to the world. Okay, let's just dive right in by tackling the most fundamental question there is. Where does your GKE cluster actually live? It sounds simple, right? But trust me, the answer to this one question is the key to understanding, well, pretty much everything else. You see, it all starts with a piece of Google Cloud you're probably already familiar with, the Virtual Private Cloud, or VPC. This is your own private isolated slice of the Google Cloud universe. And GKE isn't trying to reinvent the wheel here. It's designed to build smartly right on top of this powerful foundation. And this is the first big idea you really gotta get. A GKE cluster is not some separate thing floating off in space. It is deeply, fundamentally woven into your network. The best analogy? Think of your VPC as a plot of land you own. Your GKE cluster is the entire high-tech campus you're building on that land. It uses the same roads, the same plumbing, the same core infrastructure. All right, so we've got our plot of land. Now let's talk about the buildings and the offices inside them. The actual places where your applications are going to run. So the first thing GKE does is set up its worker nodes. And there is absolutely no magic here. These are just plain old Google Compute Engine virtual machines. That's it. They get placed into one of your VPC subnets, just like any other VM you'd create, and they get an IP address from that subnet's range. Simple as that. But here is the crucial part. Your applications, the containers themselves, don't run directly on those nodes. No, they run inside a core Kubernetes building block called a pod. So if the node is the apartment building, each pod is an individual apartment inside of it. Okay, so this leads to a super interesting problem, right? If you've got potentially hundreds of these apartments, these pods, crammed inside each building or node, how on earth do they all get a unique, real address so they can talk to each other? I mean, think about it. This is a huge challenge. In the old days, you'd be stuck with clunky workarounds like network address translation, or NAT, which is slow and a total nightmare to debug. But GKE's solution? Wow, it is incredibly elegant. The secret sauce here is a native GCP feature called alias IP ranges. The idea is brilliant in its simplicity. It lets you assign not just one primary IP, but a whole range of secondary IPs to a single VM's network card. And GKE takes full advantage of this. So, how does this actually play out? Well, when you create your GKE cluster, you just set aside an extra IP range in your subnet specifically for pods. Then, GKE's internal IP manager acts like a concierge for that block of addresses. And every time a new pod spins up, boom, GKE just hands it a fresh, unique IP from that reserved pool. And this is why it's such a game changer. Your pod is now a first-class citizen on your VPC network. It can talk directly to any other pod, any other VM, any other GCP service, all using its own real, routable IP address. What does that mean for you? No weird NAT, no complex overlays. Just clean, fast, and way easier to troubleshoot networking. All right, so our pods can all chat with each other on the network. That's great. But what about the outside world? How do we create a stable, reliable front door for our application so users and other services can actually get to it? The answer is another Kubernetes concept called a service. You can think of a service as a permanent address for a group of pods. Pods themselves come and go. They get scaled up, they crash, they get replaced. But the service endpoint, that stays constant, always knowing how to route traffic to the healthy pods behind it. Now, what's so slick about GKE is how it takes these abstract Kubernetes ideas and connects them to real, concrete Google Cloud resources. A cluster IP service, that's just for internal chatter between your apps. Node port, handy for a quick test. But the load balancer type, that's where the magic happens. It's a direct instruction to GKE to go and automatically provision a full-blown Google Cloud load balancer for you. And let's be perfectly clear, for anything real, anything your users will actually touch, the load balancer service is what you're going to use. Why? Because it's robust, it's globally scalable, and it's completely managed by Google Cloud. You get all that power without any of the operational headaches. And it gets even better. You get to choose what kind of load balancer you want. With literally one line of configuration, you can tell GKE, hey, I need an internal load balancer with a private IP for my backend services. Or, nope, give me an external one with a public IP for the whole world to see. It's that simple, and it's incredibly powerful. So we've covered a lot of ground, from the VPC to the nodes and pods, all the way up to services. After all that, what do you really need to remember when you go to design your own cluster network? The one that's not just going to work today, but will scale with you for years to come. Okay, here's your cheat sheet. And if you remember only one thing from this entire explainer, make it this. Plan your IP ranges ahead of time. Seriously, you can't easily change these later. Give your pods a big enough range to handle your wildest growth dreams. And make sure your CIDR ranges, which is just a fancy term for your IP address blocks, don't clash with any other networks you need to connect to. Getting this right from day one will save you a world of pain down the road. So there you have it. By understanding how GKE so smartly uses the fundamental building blocks of GCP, like VPCs, alias IPs, and cloud load balancers, you've built an incredibly solid foundation. You've solved the networking problem for scale, which leaves you free to tackle the next big question: is your application ready?